This question is kind of tricky. You're going to need to know a lot of like key terms, I guess. They're not really definitions, because you just kind of need to understand the story and know how it's going to relate to these two types of questions. So we're going to need to memorize some things, but I would also say that, start by narrowing your focus and really looking at the answer choices and letting them tell you what to care about here. So if we look, we have a very clear choice to make right off the bat, right? There's two kinds of answer choices. There are linear equations and there are exponential equations. And so this is where the memorization piece comes in. We need to understand what those kinds of situations are going to sound like in a story. So the key piece is that linear growth is constant growth or decay, right? If it shrinks as well. But the point is it's constant, right? The same amount of change is happening every year. Whereas exponential growth, it's a curve. It usually, looks more like this, where things are maybe slow to start, but as you go through time, you gain more quickly, you grow more quickly. We usually associate exponential growth with percentages. Not always, but it's common enough. So let's look at this story and see if we can determine which one it's going to be. The Downtown Business Association in a certain city plans to increase its membership by a total of N businesses per year. So they're talking about the increase right there. There were B businesses in the DBA at the beginning of this year. Which function best models the total number of businesses Y the DBA plans to have as members X years from now? So let's focus on the growth, right? Let's focus on that increase. It's increasing by a total of N businesses per year. So let's just, for the sake of argument, say it was 5 businesses per year, right? That number isn't changing based on the question, right? So if it's 5 businesses this year, it's going to increase by another 5 businesses next year, another 5 businesses the year after that, and so on and so on. And so 5 is our magic number. That's our increase. Whereas if it were exponential growth, what we would expect is that it would be 5 businesses this year, maybe 6 businesses next year, maybe 8 businesses the year after that, right? The number that we're increasing by would also increase. That's not happening here. So we're not looking at exponential growth. This is linear. It's a constant increase of N businesses. And that's going to be represented in our linear y equals mx plus b equation as the slope of the line. The constant increase is the slope. Excuse me. So what then do we need to decide based on next? This is the benefit of narrowing your focus, is now we don't need to think about everything at once. Now we can decide, do we need a positive b or a minus b? Well, what does b do? Remember, in our y equals mx plus b equation, which is what these are supposed to kind of mirror, the b is the starting point. So B is just that. There were B businesses in DPA at the beginning of this year. That's the starting number of businesses, B. Why would we subtract that out, right? The starting point is, let's say, B is 12, right? We're starting with 12, and so every year we're going to increase that number. And if we plug in a number for a second, and we think about X being the year, at 0 years from now, we want to have a positive number of businesses, right? So right now, the 0 year, we want our number to be positive 12. If we put in choice B, it would be negative 12, and that's weird. You can't have negative businesses. So B just doesn't make any sense with the particulars of this story. A is going to be the answer. I think this one's a little hard for where it is in the test, number 7, but these concepts of linear growth, exponential growth, getting comfortable with both types of equations, this will absolutely come up on your SAT in one way or another. So this is an important question just as a refresher for those ideas.